the triangle is going to come in handy for some of the things that we're going to do today with all the notes. And guys, I think we did a really good job being able to understand, first of all, what a polynomial function is, what degree it is, what type it is, what leading coefficient, stuff like that is. Now, we've looked at combining like terms in the past, and today what we're going to start looking at is adding, subtracting, multiplying polynomials, okay? The whole essential question here is not really, I mean, everything that we do is not going to tie exactly into the essential question, but these goals are going to be what's most important today. How about the question we're trying to address here today? Who wants that first? How can you cube a binomial? Okay. Well, our goals are to add and subtract polynomials. Okay. We're going to look at multiplying polynomials, and then you guys have, what's the guy's name? Pascal's triangle. Anybody ever heard of Pascal's triangle here? Okay, what do you know about it? Okay, what's the very top of the triangle's value up there, kids? 1. And then down there, there's a what and a what?
A 1 and a 1. Okay,
so this is pretty cool. Yeah, I think I get all excited.
I know, like, they kind of add up.
Yeah, so you've kind of had a little experience. So 1 and a 1. Okay, now, right here what you kind of do is you kind of triangulate off of these numbers like this. You always have 1s on the edge, but this 1 and this 1 make what here in the middle now? A 2, and then what's this make?
4.
Okay, and then you triangulate with a 1 down here again, all right? But this next number comes from the 1 and the 2 together, which would be 3, and this would be 3, and then what do you have on the very end again? 1. So do you understand why the next one is 1, 4, 6, 4, 1? Makes sense to you? Yeah, I didn't get it. Oh, I'm sorry there, Sterling. Did I missed notes for Sterling. Did anybody else get missed at all? Jade, did you get yourself one?
Yeah.
Okay. All right. So we'll kind of talk about that. That's going to be kind of a lifesaver for what you do today, okay? This is going to help a lot as we move forward. Probably more tomorrow than today, but just understand that that triangle, you might want to write down that this is for 3.2 notes at the top of that, okay? And then down at the bottom, we also have Binomial Theorem down there, okay? How many of you guys got your calculator handy right now? How many of you have your calculator handy? Might want to get that out. I want you guys to learn how to do this right now. How about that side of the room? Do you guys have triangles over there?
Yeah.
Okay.
What? I didn't pass out the triangle. No. Yeah, let's.
All right. Did everybody get the notes in the triangle now? Good to go? All right. Well, here we go, kids. Questioning in this. How can you cube a binomial? And again, we're looking at adding and subtracting polynomials. We're going to multiply polynomials, and then we're going to use Pascal's triangle and the what, kids? Binomial theorem to expand binomials. What I want to make sure before we get into tomorrow is if everybody has a calculator. Do you guys have, I'm going to put this in here, okay? Do you guys have like a probability button on your calculator where it says PRB? Yep. Okay, do you guys have a probability button there? How many of you guys, can I hold this up here, Cheyenne? How many of you guys have a calculator maybe like this one here? Just a different color, okay? It's kind of like the iPhone of calculators. This is like, this is my favorite one, okay? All right, what I want you guys to do is this. If you have like what Cheyenne has, I want you to hit 3 first in your calculator. Okay. And then do you guys have a probability button at all?
Is it PRB?
Yep, it says PRB on it.
Yeah, I do. Oh, and I'm going to see.
You're going to hit the math button. Probability. You're going to put 3. Makes sense. 3 in there. Put 1 in there. Makes sense? Okay. What I want you guys to do, if you have the calculator like Shannon's, is this hit 3, probability, or PRB button. Do you guys see something that comes up like this as an option? Like a subscript N, capital C, small r in there?
This is NPR, NCR, exclamation point.
You want the NCR, so you're going to slide to NCR, hit enter when you do that, and then put a 1 at the end, and then hit enter and see what it gets you. 3. What do you guys get when you punch that in? I think you've got it here somewhere.
So 3 and then PRB.
And that's okay, we'll figure it out, buddy.
NCR equal. And then what?
1.
Oh, 1.
And tell me what it kicks out when you hit enter. Okay, so you're going to hit.
So read.
Nope, you're going to hit 3, and then you're going to shift, and then you're going to hit NCR, so it's really, got it? Did you figure it out? Okay, what are you guys getting when that comes out? Maddie, did you get yours figured out? How to do it? Did you figure yours out, Gabriel? You figure yours out?
What do you do after NCR? Like this?
You put a 3 and a 1 in. Just put 1 in for your R value. And then hit enter. Got it? Okay. All right, so it looks like we all know how to do that. So tomorrow that'll be very handy. So this is called about combinations and stuff, and this is all going to tie into binomial theorem tomorrow. So make sure you bring your calculators with you tomorrow, okay? All right, let's get started on the notes. Let's hit the vocabulary here first. First of all, what is Pascal's triangle? Well, Pascal's triangle we kind of talked about already. It's on the handout. It helps with solving binomial theorems. So I'm going to write down that Pascal's triangle is on the other handout. And what this does is it helps us expand products of binomials. Okay, it helps us to expand products of binomials. Okay? All right, then the binomial theorem, that's also on the handout. It's just a big formula. It's just a big formula, and we'll talk about this a little bit more tomorrow. But it's on the other handout. And it's going to be a way to expand. When I use the word products, what operation are we talking about, kids? Products. What operation is that mathematically? Multiplication, right? Okay. So it's going to be a way to expand products of polynomials. All right? It's going to help us expand polynomials. I know I crunched that word in there, but it's a way to expand products of polynomials, okay? All right. Anybody remember what like terms are?
Like two X's or 2 Y's.
Mm-hmm. So like terms have the same variables and what, kids? Same variables and exponents. Okay? So for instance, if you had like 3xy plus 7xy, what would that combine to, kids?
10xy.
10xy. And then the identity? An identity is like saying this. How about I do this? How about I say 2x? And it's not really this. An identity is saying no matter how you expand something or whatever, they're kind of like equal expressions. They look like two different expressions, but they're equal, okay? So I'm going to say two expressions that are equal. Maybe we'll make this very simple for you. How about we say something like this? If I have 2, then in parentheses x plus 2, what's another way to write that expression right there? 2 times the quantity x plus 2. X plus 4, you bet. Very good. So they say that the 2 times quantity x plus 2 is an identity for 2x plus 4 because equivalently they are the same thing. Right? All right, vocab-wise, again, we'll talk more about Pascal's triangle and binomial theorem and how that's going to help us expand products of polynomials tomorrow. But make sure you have that sheet with you. I think you guys know what like terms were from before, and I think you know what an identity property means. So let's rock and roll today. Let's get through this. Make sure we know what we're doing here. All right. Ooh, what's the first thing we're going to look at doing here, kids, in example 1? Okay, vertical format and horizontal format. Now, guys, I'm going to tell you right now, I don't care which format you choose, but what I do want you to do, that sounds really goofy. Want you to do. You guys alive this morning? Pinch yourself. Make sure you're awake right now, would ya? Maddie's like, Parsons, knock it off. Go ahead, Jaden. Yep. Okay, what I do want you to choose today is the following. You choose the way that you like best for yourself, okay? Choose the way that you like best for yourself, okay? I like doing stuff horizontally. I think it works easier to do everything horizontally, okay? So the first thing it says to do, guys, what are we doing here? Help me. What's it say? Adding. We're going to add this first polynomial to the second polynomial. In what format? Vertical format, meaning up and down. One on top of the other. So I'm going to write this top one again. 2x cubed plus x squared minus 3x plus 4. And to that, we're going to add the other one. Now watch what I do here, kids. I'm going to add, all right, I'm going to line things up so that they match here. The x cubed matches the 2x cubed. Those would be like terms. So I want to put x cubed here. Plus the 7x squared. I'll put that right under this one. Guys, is there an x term in this one right here, or x to the first term at all here? Is there an x term in the second polynomial? Okay. Well, x to the first? No, we have x to the third and x squared. Okay. This minus 2, what should I line this minus 2 up with? The negative 3x or the plus 4? Yeah, I'm going to put this minus 2 over here, though, because it helps me kind of line things up. My like terms are kind of divided together. So help me add stuff here, kids. What's 2x cubed plus the 1x cubed? 3x cubed. What's 1x squared plus 7x squared?
8x
squared. Let's see, the minus 3x plus, there's no x in here, so what are you just going to have there?
Negative 3x.
Minus 3x. Plus 4 plus the negative 2 is the?
Plus 2.
There it is.
That's the answer?
That's the answer. Okay. Adding polynomials. So you're simply, whenever you add polynomials, all you're doing is combining. You're just simply combining like terms, kids. Now, that's a vertical format. You know what? I don't mind this here for addition. It's pretty simple. You know, if you line up every degree, match the degree with the other degree in the other polynomial, that works pretty well. Now, horizontal format, you know, it's the same thing. I prefer horizontal format, and I'll tell you why here in a little bit, because I've got to be honest with you. When you multiply, you're going to do that horizontally as well. Okay? So this next one right here, I'm going to add this how, kids? Okay, so I'm just going to rewrite this. Negative 4y to the third plus 2y squared minus y plus 2. And now what are we adding to that, kids?
Y squared minus 6y plus 9.
Okay, I look for the highest degree. What is the highest degree in here, kids?
3.
Okay, when I do this horizontally like this, I'm going to say, well, are there any third powers in here to put together with this? Are there any, kids? Nope. So we know we've got negative 4y to the third. And when we do horizontal stuff, I like to kind of cross stuff out like this. Okay? What's the next degree that we should probably put if we're writing this in standard form?
To the second power.
Okay, is there any other, how many terms with second power in there?
2.
Okay, did I forget one? Yeah, I did. This should be 2y squared, shouldn't it? So we've got a positive 2y squared and a positive y squared, which would combine to be
3y squared.
plus 3y squared. And again, I don't doubt that you know how to do this part right here, but help me finish it. How about some y's, guys? I've got a minus y and a minus 6y. What's that going to combine to?
Negative 7y.
Mm-hmm. And then the plus 2 and the plus 9 is?
Plus 11.
What do you guys think?
I think that's easy.
Adding is very simple, isn't it?
Yeah.
You just combine like terms, right? So let's take a look at the second page, okay? Because we said today our goals were to add, subtract, and multiply polynomials. Any questions? First page. Give me a show of hands. How many are on board with me right now with this? That's pretty simple, right? And like I said, I told you, I think this will start out pretty easily. Now, example 2, what are we getting into?
Subtracting.
Subtracting. And this is where you need to start to be careful. And again, okay. Subtract 3x cubed plus 5x squared minus x plus 8 from 5x cubed minus 4x squared minus 3x plus 1. What format are we going to use here, kids? What format am I using in the first one? Vertical. Okay, so I'm going to put this first one up top. Is the first one in standard form? Are we okay standard form first? Okay. Second one would be on the bottom, exactly. Yep. So I'm going to start right here. We're going to start 3x cubed, so we're going to subtract this. Oh, good catch. Good catch. Xavier is on the ball today. Everybody turn to Xavier and give him a thumbs up quick. Attaboy. I didn't read this correctly. Thanks for doing that. It says subtract this polynomial from this one, right? So what should go on top, Xavier? Xavier, that's awesome. Thank you for saving me. I'm glad someone's looking out for me. So we're going to go 5x cubed up top minus 4x squared minus 3x plus 1. Now you have to be very careful on this, kids. We're going to subtract what from this?
3x to the third power plus 5x squared minus x plus 8.
Notice how I'm lining up like terms again, kids. Okay, but kids, when I subtract out front here, and I'm going to highlight this in red, when I subtract out front here, you've got to be very careful because, help me out. If I'm doing this right here, you guys agree that the x cubes 5x cubed minus 3x cubed would simplify to what? 2x cubed. Okay? Now be careful on this. What kind of 4x squared am I starting with here, kids? Negative 4x squared, then minus 5x squared would be? Okay, so you start at negative 4, right?
Oh.
And you're subtracting 5 more, right? So where's that going to land us, kids? Okay, so when you subtract a 5, that's going to make this more negative, isn't it?
Yep.
So wouldn't that be negative 9x squared, or minus 9x squared, in other words? Right?
Yep.
Okay, here's the tricky part, and don't get caught on this. What kind of 3x am I starting with up top, kids?
Negative 3x.
When I subtract a negative x, that's really like adding an x, okay? So what's negative 3x really?
Negative 2.
Minus 2x, good. And then lastly,
Plus 9.
1 minus the 8. 1 minus 8.
Oh, wait. Why? Oh.
Say it again. Yep, minus 7. Got it. There it is. Okay. Now subtracting, sometimes I think the vertical format is good. I'm a horizontal guy. I just like the horizontal format a lot better. This one here, pay attention to what I do. It says subtract this mess from this mess right here. Okay, so what are we starting with really, kids? 7z squared minus 4z. Now this is the part about minus, and you got to be careful on this. If you do horizontal format, minus it. It's saying you're subtracting that whole expression. So that second expression needs to be put in parentheses. So when you subtract a second one, always put that second one in parentheses. Hear what I just said. When you subtract that second one in a horizontal format, make sure you put what around that second one. And I'll tell you why. Because this minus right here, this subtraction, has to change the signs of everything that you're subtracting. So in here you have a 5z squared minus z plus 3. Okay? All right, let's talk. My leading coefficient out here of 7, coupled with that degree 2 power z, 7z squared. Are there any other z squareds in here to put together with that?
Yes.
So this is going to be really 7z squared minus what, kids? What's that going to get you? Okay, we've taken care of those two. Now, what kind of 4z do you have here? It's negative 4z, but you're going to minus a negative z. So we're really going to add or subtract z from that negative 4z. We're really going to add. So this is really negative 4z right here plus z. What's negative 4z plus a z, kids? Negative 4 plus 1. Wouldn't that be minus 3z, kids? Yes? No? Yes? Okay. And then what do I have last here? What's left? Yeah, this is minus 3. This negative sign changes that sign to a minus 3. Okay? So the big idea here when you're subtracting, if you're going to choose to stay in horizontal format, you have to understand that that second part in the subtraction gets put in what? Parentheses, okay? Parentheses, all right? Adding, subtracting polynomials. Give me a thumbs up or thumbs down if you're good on that. Are we pretty good on that? Okay. Anybody have questions on those right now? All right. Well, can I ask you guys a question? Can I ask you a question? What if I told you I knew exactly what the easiest way to multiply stuff was, and I chose not to show you the more difficult way? What if I just kept this simple for you? Would you be okay with that? Okay. Can I tell you, I don't care what you do for addition and subtraction. I think that's up to you and what you're most comfortable with. That's what I think, okay? But what I know is that multiplying polynomials works a lot better if you do it horizontally, okay? So can we just say down with vertical today on multiplication? Okay, let's do that, okay? So in fact, is it okay if I do this first one here? Can I do this first one here? And let's change vertical to what? I'm going to tell you guys, if you have to multiply polynomials, do it horizontally, okay? It's just a lot easier. It's just a lot easier that way. So, here we go. We're going to take what times what, kids? Okay, anytime you multiply stuff, always put each polynomial in parentheses. So we're going to take 2x squared minus 3x plus 5 times what, kids?
X minus 2.
Okay, now I think you may have done a little bit of this before. I'm not sure how large the polynomials were for each set, but let's see what you remember. Basically, guys, I need to take everything in here times everything in here, and then in the end, we need to combine like terms. So I'm just going to start this out. I'm going to be drawing bunches of arrows up here, and that's okay. What's 2x squared times x?
2x to the third power.
2x to the third. Yep. And then I need to take 2x squared times what, kids?
Times 2, negative 2.
Yep. So what's 2x squared times negative 2?
Negative 4 squared.
Okay. So I've taken the 2x squared times everything over here. Now I need to take what times everything over here?
Negative 3x.
So I'm going to take the negative 3x times x, which would be minus...
Negative 3x squared.
Yep. And then the negative 3x times the negative 2 would be...
X
So plus or minus, Jaden?
plus
Yeah, good. Now what do I need to do, kids?
5 plus 5x minus 10.
Plus 5x, because that's the 5 times the x right here, right? And then what was the last part of this?
Minus 10.
Okay, here's what I want to tell you about multiplying, kids. When you start this out, take a look. How many terms do I have right here if I count them? I have 1, 2, 3. How many terms are in there after I fuck? 6 of them. How many terms were in the first set?
5,
The first set.
3.
There was 3 terms here. How many terms here?
2.
What's 3 times 2? Which means 3 times 2?
6.
6, which means there should be how many terms here?
6.
Am I done at this point? Or are there some things that we can do for simplification now?
Simplification.
Absolutely. So let's simplify. You guys tell me what this mess is going to simplify to. I'm going to squeeze it in up top here, all right? So I'm going to make an arrow that says this is what it becomes.
2x to the third power.
2x to the third. And here's one other thing I want to tell you. Make sure you put stuff in standard form when you're done. Okay, I'm listening. I'm sorry to interrupt.
Minus 7x squared.
Good.
Plus 11x minus 10.
Jaden, you are speedy today. Plus 11x.
Yeah, I'm in like this mood. I'm ready for it.
You're rocking the math today. I love it. That's the worst looking 11x I've ever drawn. Let me clean that up, kids. You said plus 11x, is that right?
Yep.
Minus 10. Very good. Okay. You guys try this one on your own. Yeah, there you go.
I don't know if it would help, but like, I like to put the biggest one first.
That's fine. You can do whatever you want.
That order.
Because if you look at the second one, that's where I was going with that. The y plus 8. Put the short one first.
Wait, can we put the long one first?
You can put the long one first if you want. I like putting the short one first. Do what you want. You guys try that one on your own. What? Here's the deal about it. Either way you do it, you're going to get it right. So you get, and again, it's going to go back to personal preference right there.
Should have went to the game last night. Parson was crazy.
I heard. I had a meeting with Robert for basketball.
Oh, Robert.
Yeah. And then my girls, I haven't seen my girls in the last couple of days, it seems like, so they were at swim practice, and I went home and spent an hour and a half with them before they had to go to bed, so
That's nice.
yeah.
It was crazy good.
Carson, did you hear that we got in trouble for cheering? Caitlin came over and yelled at us for cheering. Columbus was making like,
You go to
Just
bed.
told us in a
They're pretty much-
meeting you guys were good at cheering last
they
night.
pretty much roasted us.
Your school policy.
But we said daddy's money, and the kid's like, no,
Not that one.
no.
I would say something on that too.
No, you wanna know what they said, what they were saying?
I don't want to hear that. Was it bad?
They were talking about jewels.
Oh, Jesus.
And then
Oh
they
yeah,
talk-
Jewel in school.
They
is-
said something about our cousin, like
Jewel
cousins.
is cool.
Something about.
You should have
Then
seen.
they said farmers
seen
only.
Kate.
You should have said the only thing that matters at the end of the night is the scoreboard.
Wait, hold on.
You should have seen Kate
What
when
was
they
that
were
they
saying
said?
Jewel in school.
Oh,
Like,
yeah,
Oh
Carson.
no,
They
not
were
good.
saying-
I don't want to hear this.
They were saying like.
I don't want to hear
Yeah,
this.
like-
I don't want to hear this.
What did they say?
Okay, you guys have an answer here?
What?
What do I need to put around stuff?
Daddy's one was fun.
What do we have?
2y to the third power plus.
Okay, so take a time out. Let's go through the whole process for me first, okay? So what do I need to write first?
2y squared
Okay,
minus.
I'm going to go the other way. So I'll put your 2y squared. I'm listening. Minus 4y plus 3 right here. What do I need to put around that, Jaden?
Parentheses.
Okay, and then what else do I need to do?
Y plus 8.
Okay. Now, guys, up here, you know, it's personal preference. Xavier was kind of ahead of me on this, and that's awesome. Sometimes that's nice to put the shorter one out front because you feel like you're multiplying less. I don't care what you do. It's entirely personal preference, okay? But what would y times y squared get you?
3y squared.
Careful.
2y squared.
2y to the
Third power.
third power. There we go.
That's what I meant.
Okay. Y times minus 4y, kids?
Negative 4y to the second
Negative
power.
4y to the second. Okay. Then I've got to take y times the 3, which would be,
3y.
okay, now we've got to take 8 times everything in here, so
16y squared.
minus 32y, and then what's the 8 times 3, kids? Okay. So how about combining like terms now? 2y to the third,
3y
good?
to the third,
Okay.
and then it would be 12y to the second.
Okay, so these combine to 12y to the second, is that right?
Yeah.
So plus 12y to the second,
And then it would be
minus 29y, we all agree minus 29y?
yeah. And then plus 24.
Very good. How many had that? Good.
Totally.
You were on your way, right? Okay, very good. Okay, so let's finish up here with example number 4 right here. We have to multiply 3 binomials, and then we'll finish up stuff tomorrow. Make sure you bring what else with your notes tomorrow? Make sure you bring the triangle with you, because we're going to start taking care of that stuff tomorrow. Okay, guys, instead of multiplying 2 polynomials together, how many polynomials are they asking you to multiply? 3 of them. Okay, no problem. Here's how you do this. You start with 2 of them first. Okay, so I'm going to write down as this here, kids. This is going to become x plus 2 times x minus 1 times x minus 3. Okay? Now what I'm going to choose to do is multiply the first 2 together to create another polynomial. Okay? So maybe make a note over here. Multiply the first 2. Okay, so you guys help me do the first 2. What's x times x? X squared. What's x times negative 1? Negative 1x. Then I've got to take 2 times x, which is what? So plus 2x. You guys agree? And then what's the 2 times the negative 1? Okay, so how many have I multiplied together already, kids? 2 of them. Now I need to take that mess that I've just created and times it by What? Okay, can I cheat you a little bit on this? I can save you a little bit of work. Because if you look in the middle of this first one, after we multiplied these first two binomials together, was there anything I could have combined in here? The negative 1x and the positive 2x in the middle could really be what value right here, kids? This could become what? Positive 1x, right? So in the middle, this is really plus 1x. All right, so here we go, guys. We're going to take x minus 3 times everything over here. So help me out. What's x squared times x? X to the third. How about the x squared times the minus 3?
Wait, where's the 2x at?
We combined it. We combined that middle one, negative 1x. Look what you have right there. Negative 1x plus 2x. Wouldn't that combine to be a positive 1x? Wasn't this one right here, x times negative 1, negative 1x, Jaden?
Yeah.
Wasn't 2 times x positive 2x?
Yeah.
What's negative 1x plus 2x going to combine to in the middle here now?
Oh, so you just didn't.
I just put them together to save me a little bit of time. Okay? All right. The x squared times the minus 3 would be minus 3x squared. 1x times everything makes plus 1x squared. Minus 3x. And then the negative 2 times everything is minus 2x plus 6. Okay? So to that point right there, kids. Ooh, did I do something wrong? This should be a minus 3x, shouldn't it? Negative 1x times, yeah, it should be a minus 3x. Okay? All right, kids, simplest form, standard form. What are you going to end with here? What you going to end with?
X cubed
Yep.
minus 2x squared
Yep.
minus 5x plus 6.
What do you think?